Okay, we're simplifying the sum or simplifying the difference, depending on whether we're adding or subtracting. This first one is simplify the sum, because we're adding. Um, how do you want to approach this? Well, we want to look at this sign that's in front of the second polynomial and say, is it negative? Is it going to change the sign inside of everything? And no, it's not negative, so it's not going to change the sign inside of everything. So if we were to, for example, distribute that through, that's really a positive 1/2, right? Right? Positive 1 times 2u cubed gives you the same thing, 2u cubed. Positive 1 times negative 7u gives you negative 7u. And positive 1 times 6 gives you positive 6. None of those things change because it's just a plus out front. So now we can just then say, okay, now we're then going to combine the like terms. We've got 2u cubed and 2u cubed. That becomes 4u cubed. I see that down here at D. Okay? And then we say, excuse me, for the next one, the u squared term, there's only one u squared term. There's no u squared term in the second polynomial. So we just got 6u squared. And I see that also in D. And then we've got a u term, negative 7u, but there's no negative 7, or there's no u term in the other one. So we just got negative 7u. That's also in D. And we've finally got two constants here. We've got the positive 3 and the positive 6, and those combine to positive 9, and I see that in D as well. So D has all of the required parts, and so it's D. Okay, let's do the same thing but with the difference this time. But with these next ones, when we're finding the difference, we've actually got to change the sign of everything inside. Okay, so let's follow that. Here, because we're subtracting, that means we're doing the negative of, for example, negative 7x to the fourth. So that's going to turn that, when we distribute that through, into positive 7x to the fourth. And then we're going to subtract that negative 5. That's going to turn it into a positive 5. And we're subtracting the negative 9x. That turns it into a positive 9x. Okay. And some of you just go through and you say, that was negative, it's going to be positive. Like that. That was negative, it's going to be positive. That's negative, it's going to be positive. That works when they're all negative. It's hard to turn a positive into a negative that way, though. So I'm just going to write it above. Now, let's combine what we've got. Do it the same way. Okay. We have x to the fourth terms. Let's see. We've got negative 5x to the fourth and positive 7x to the fourth. Negative 5 plus 7 is 2, so 2x to the fourth. So that A has that, so does D. Let's do the next one. We've got our next term that we've got is an x term. We've got a negative 7x here. And we've got a positive 9x here. Negative 7x and positive 9x is positive 2x. A has that. So does D. And then finally, we've got our constant term of positive 5 here, and positive 5 here, and positive 5 makes positive 10. And that's D. Well, C also has positive 10, and so does B. But those are already eliminated because they didn't have the other terms correct. So the only one that's got all of the terms correct is D. So it's D. Okay, let's do that one more time. Down here in the bottom, we're subtracting. So this second polynomial, the sign of everything inside changes. That 8w squared becomes negative 8w squared. That 2x becomes negative 2, I'm sorry, 2w becomes negative 2w. And that negative 3 becomes positive 3. And now, when we run through, we see what terms we've got. We've got a w squared term. We've got 4w squared minus 8w squared is negative 4w squared. A has that, so does C. The next term that we've got is our w term, negative 7w minus 2w. Negative 7w minus 2w is negative 9w. A has that. C doesn't, so it looks like we're going with A, but let's verify it at the last bit. We've got negative 6 for a constant and positive 3. Negative 6 and positive 3 go together to be negative 3, and that is what A has. So A has all of the required terms. That's the answer.